So we have to move forward on the absolute belief that the space-time manifold can be affected by EM radiation in an efficient manner. That leads to the idea of the zero-point field and the polarizable vacuum model.
And it's a very simple concept. In the case of the usual general relativity approach, we talk about light from a star coming by, and when it goes by the sun, it gets bent. And we think of that in terms of the space-time warp and the dimple, and it kind of rolls around. But another way of looking at it is that, because we know how light gets bent ordinarily in the laboratory, it's put it through a lens. And so another view, and there's a long history of this approach as well, is that the sun and the planets and so on, in effect, change the refractive index of the vacuum. And in fact, the refractive index is higher toward the sun than it is further away. And therefore, again, you would predict that as the light ray comes by the sun, because it's entering a region where the refractive index is higher toward the sun, that would account for its bending.
So in that sense, just following Einstein's path, we can easily accommodate the zero-point field and explain something that, in a sense, general relativity does not. It doesn't explain where the weight of an object comes from. It explains why you would orbit around an object following a geodesic. But if you're held fixed in a gravitational field, where does that weight come from? General relativity doesn't really tell you that. But general relativity combined with the zero-point field does. So that's I think, a point in favor of the zero-point field interpretation of mass and inertia and gravitational weight.
So in that sense, the polarizable vacuum is just an alternate interpretation of the same measurements that are interpreted as space-time curvature under general relativity.
Now, a deeper question is, why is space-time curved at all? Why does matter produce that effect? And it's possible to conceive of the idea that matter has an effect on the dielectric properties of the vacuum itself.
So on top of what would be termed the electromagnetic zero-point field, we superimpose upon that the energy density of the Earth as a field, so we've got like the zero-point field plus the field of the Earth that are superimposed upon one another to give us a gravitational field, to give us a gradient in the energy density with respect to altitude. And it's that gradient in the energy density that we see as 1g of acceleration.
So the assumption that you first make up, that you start off with, is that electricity, gravity and magnetism is unified. Now that's consistent with the zero-point field model, it's consistent with the polarizable vacuum model, and it becomes the heart of the electrogravimetric model. So between these things, between what we understand of zero-point field theory, which is really quite broad and not very well defined, to the polarizable vacuum model, which is a bit more stringently defined, it's got structure to it, to the electrogravimetric model, in fact it's not a model, it's a method that gives it total structure, absolute structure. Now based on that absolute structure, we now have something that we can work with.
What EGM is intended to do, it's intended to give engineers a tool by which they can understand and modify gravity.
If mass is the result of electromagnetic discourse between particles, then there's every reason to suppose that by interfering with that discourse, you can modify the mass.
We use electromagnetic fields that we apply into interference patterns that generate accelerated reference frames. When we have an acceleration, that acceleration is equivalent to gravity, just because of the equivalence principle in the same sense. So what we engineer with EGM is, by similarity, equivalent to a gravitational field.
Everything in nature has a point, has a frequency that if you rattle it, it'll break. And there's no absolute reason without experimental proof why the space-time manifold shouldn't be like that too, perhaps. If the space-time manifold does have a naturally weak point, a point of natural weakness, natural resonance that you can rattle, I don't know what you'll find.
It could lead to things like artificial gravity, electric motors that can defy gravity. It could lead to modification of the speed of light, warp drive, things like that, electromagnetic propulsion. And so in that regard, EGM is a tool that can be used to help facilitate these things and make them happen.